For this particular problem, we're going to be asked to find different parts of this quadratic function, and we're going to be asked to graph the graph of this quadratic function. We know that this is a quadratic function because one of the terms is squared. That first term, 1/3 x squared, that x squared is what makes this quadratic, and the graph of this quadratic function is going to be a parabola. So let's go through and let's just see if we can't find the information here, as much information as we can. So all quadratic functions, they all take on the form ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is a constant. If a, the coefficient of x squared, if it's positive, then your parabola, the graph of this function, will open up. And if it's negative, then it'll open down. Okay? So for this, the vertex, a way to find the vertex is by using the formula negative b over 2a. That expression, that formula, gives us the x value of the vertex. And once you know what that x value is, then all you need to do is plug that into the function, and that will tell us the y value of the vertex. So let's go ahead and let's plug in 4 in for b, and then we're going to plug in 1/3 in for a. And we'll simplify this, so negative 4 over 2/3. Well, negative 4 over 2/3, that's the same thing as saying negative 4 divided by 2/3, if we want to write it this way. And if we want to go ahead and rewrite this as a multiplication problem, we can write this as negative 4 over 1 times the reciprocal, 3 over 2. And if we do the math, you're going to get negative 6. So the x value of the vertex is negative 6. Well, how do we go about finding the y value of the vertex? We'll just take that negative 6 and plug it into your function. So everywhere you see an x, just substitute it with negative 6. 1/3 negative 6 squared plus 4 times negative 6 plus 2. Plugging it in is going to give us negative 10. So the vertex is negative 10. And the axis of symmetry, the line, the vertical line that cuts this parabola in half, will be x is equal to negative 6. So just make sure that that whatever the x value of the vertex is, well, x equals that. That's the equation of the vertical line that cuts your parabola in half. All right. Well, let's go in and let's see if we can find the x-intercepts. Well, the x-intercepts are those points on the graph where y is equal to 0. In this case, your function is going to be 0. Where does the graph cross the x-axis? So we'll substitute 0 in for f of x, and we want to solve for x. We want to find out when does this expression, when does this quadratic expression, when does it equal 0? Well, I don't like working with fractions because fractions just make more tedious work. So I like to go through and get, actually that's not a negative 1/3, it's 1/3. The coefficient of x squared is 1/3. I want to get rid of these fractions, and so I'm going to go through and just multiply both sides of this equation by 3. That's the denominator there. So if I multiply everything by 3, that'll get rid of that fraction. So I'm going to have 0 is equal to x squared plus 12x plus 6. I just multiplied both sides of the equation by 3. The quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. This is a formula that you'll want to memorize. This is a very important formula. And what this formula does is it allows us to find the x-intercepts, or the zeros, of the function. So plugging in the values for b, we get, and remember we're using the equation up above, so we're going to plug 12 in for b, we're going to plug 1 in for a, and 6 in for c. We're just going to plug in all those numbers, and if we go through and simplify, we're going to get negative 12 plus or minus 144 minus 24, all of that over 2, and that's going to be 120. All right, 120. Can we rewrite 120 so that one of the factors is a perfect square? Well, 120 is 4 times 30. And we know that the square root of 4 is 2. So we can rewrite this as negative 12 plus or minus 2. We're going to leave the 30 underneath the radical sign over 2. Now let's simplify this. Let's carefully simplify this. So what I'm going to do is I'm going to split this equation up into this expression, sorry. I'm going to split it up into two fractions with a common denominator of 2. So I'm going to write negative 12 over 2 plus or minus 2 square root 30 over 2. I'm just splitting it up from one fraction into two separate fractions. And when you simplify this, well, negative 12 divided by 2 is negative 6 plus the 2's in that second fraction are going to simplify. So all you're going to have left is the square root of 30. That's one of the x-intercepts. And then the other x-intercept is going to be negative 6 and then minus the square root of 30. Those are the two x-intercepts. All right, now let's go through and we're going to find the y-intercept. Well, the y-intercept happens when the x value is 0. So if you substitute 0 in for all the x variables, that's going to tell us what the y-intercept is. And conveniently enough, the y-intercept is always going to be c. It's going to be that constant. Because when you substitute 0 in for x, those other two terms, the x squared and the x term, they're going to be 0. They're going to end up being 0. So that constant, that number 2, that's always going to be your y-intercept. All right, well, let's see if we can't go through and graph this information. We know that the vertex is negative 6, negative 10. That's our vertex. We know that this parabola opens up because a is positive. A is 1/3, and that's a positive number, so this parabola is going to open up. We know that the y-intercept is 2, so there's a point on the y-axis at 2. We know that the axis of symmetry is x equals negative 6. It's that vertical line that cuts straight through the vertex. Well, if that's the case, then directly opposite that 0, 2 is going to be another point at negative 12, 2, because that axis of symmetry cuts our parabola in half. So on one side you're going to have 0, 2, and then directly opposite of that you're going to have negative 12, 2. So there's 3 good points that we can use for our parabola, and we can kind of sketch our graph. The domain of all quadratic functions is negative infinity to infinity. Remember, the domain is represented by all the x values. And the range, well, the smallest y value we have here is negative 10. We put a bracket there because it includes negative 10. And the largest y value, well, this goes all the way up to infinity. So that's how we go about finding all the information to graph a quadratic function.